Hello, my name is Mason Dana, and I'm going to show you my code for the fitness problem in our midterm. The first thing I did is I set my working directory. So here you can see it's very specific to where I've saved it. In order to do this, you just go to session button, set working directory, and to source file location. So if you do this, it will save to wherever this information is saved in your computer. Now, if you don't know where that is, or if this isn't working, you can always choose the directory manually. And it's good not to choose it exactly, but maybe the folder that it's in. And then I set the rest of these, and this will give me a sort of table here of the actual data. So this is just the raw data, and it's really dense, as you can see. There are several, spinning wheel of death, oh no. But there are many, many rows, so it's very hard to read and manipulate. So that's why we're going to be using R code. So the first problem here is show your R code to find out how many rows are in the fitness data frame. So the data frame is what I just showed you. So manually, you would have to scroll all the way to the bottom, and as we saw, my computer kind of froze up a bit. But in order to do that, you can just use the function nRow and specify in what. So number of rows in the data frame fitness. So if we run that, we can see that it has 2,706 rows. So it's a lot of rows. So then show your R code to find out the column names for the fitness data frame. So again, we're just using a very simple function called call names, so column names. And then we're specifying that we want it in this fitness data frame. So if I run this, we get this here, where we see that the column names are X, gene, ORF, measurements, YPL, YPE, and so on. I'm not going to name all of them, but you see that there are a lot of columns. So our third question is, show your R code to find out the row where ORF is. Where the ORF, so we know that that's a column because we just saw that down here, is YAL007C, and the gene is, so in the column gene, so we see that that's a gene as well, like that's a column as well, and we want that gene to be ERP2. So where does this happen? So in order to do this, we use this function. So we're looking within fitness, the fitness data frame, but we're specifying here that we want the column named ORF within the data frame, where equals, we use this double equal sign here, YAL00C. And we use an ampersand here, or the and symbol here, because we're looking for two things at the same time, where the column gene within the fitness data frame is ERP2. So if we run this together, we get this really long type out, but here on the side, we see 6 for both of them. So we know that both of these, in row 6, the ORF will be YAL007 and the gene will be ERP2. So this next question says, show the R code to find the row where the gene is FET3. So this is essentially what we did above, but it's just asking one thing. So again, we're looking within the data frame fitness, and we're specifying here that we're looking at the column gene within the fitness data frame, and we want it to equal FET3. So if we run this, it says 1001. So again, we're looking at just there we go. We're looking at just this. So this is 1001. So we know that the gene is FET3 in row 1001. So here it's asking to show our code to find the average value in fitness YPD, so in the row YPD. So in order to do this, we need to use the mean function, and we're specifying that we want the row YPD. And we use this function here at the end so that it prints out something that makes sense to us. So here, if we do that, the mean in the fitness, in the YPD column is 0.9736503. So lastly, it's asking to see if there's a correlation between YPD and YPG. And so here, I'm just going to do a simple plot. Oh, it's already up. So if we see this plot over here, we see that there's a very dark line here. It's not all just scattered randomly. So yes, there is a correlation between YPD and YPG. And I hope this was educational. I hope you enjoyed this, and have a great day.